figure out if this converges. And what's the first thing I told you should check if you're checking to see if a series converges? Does an go to 0? Does the sequence go to 0? The sequence being the sequence of terms generated by this explicit formula. So you test that. The thing you focus on is sine n. What is sine n always less than or equal to? 1. What's it always greater than or equal to? -1. So at one extreme, you would have 1 over 2 minus 1, and at another extreme, you'd have 1 over 2 plus 1. What are those numbers? That's 1 over 1 and 1/3. So you know that all of the values that you're adding together have to be between 1 and 1/3. Therefore, you know that the limit as n goes to infinity of 1 over 2 plus sine n doesn't go to what? 0. Therefore, divergent. And you get to star in your own teen movie. Alternating series test. You know an alternating series test converges if 3 things are true. What are those 3 things? The first one is alternating. Is it alternating?
Yeah.
Yes, it is. What's the second thing it has to be true for it to converge? It what? Has to go to 0. Does it? Does it go to 0? As n goes to infinity, does that go to 0? Yeah, it sure does. What's the last thing that has to be true? Do you remember? The terms have to be, you can think of it the way I like to say it, the absolute value of the terms needs to get smaller, right? They say it as like an plus 1 is greater than an, right? Where an is the non-alternating part of that. So if you ignored this, they would call an 1 over the square root of n plus 1, right? That's what, in the formulas you see, that's what you see written. The other way you can think of it is just the absolute value of it. It has to get smaller. It has to get smaller. Does it get smaller? Basically, is an plus 1 always less than an? Is that true? As n gets bigger, does the absolute value of the terms get smaller? Yes, it does. Therefore, what? It converges.
So when you like write in the plus 1, or like I'm just for like a more complicated series, would you write the plus 1 as like root n and then have like the plus 1 in the root?
Correct. If you, I mean, like if you attempted the ratio test on this?
Right.
Yes.
Okay.
Correct.
So
Literally wherever there's n, put parentheses and put n plus 1 in it.
Okay.
One of the most common mistakes, people don't put the parentheses in, and then that one like fades away or like migrates and has a little pilgrimage.
Yeah, because I was looking at like another one and I couldn't.
Yeah, like if you saw that, you just literally say the limit as n goes to infinity of 1 over the square root of n squared plus 1. You can just say that goes to infinity. How would you prove that? How would you prove that? You do some division. You divide by the square root of n squared, and you can say you can flip it over. But that for this, the cutoff level for where we are right now, you can just say that goes to this goes to 0 because the denominator goes to infinity. Yeah. Yeah, you're computing an integral of this thing, right? Like this. What do you need to use to? What kind of integral is this? What kind? Improper, right? Improper integral, right? So we're gonna have to use a limit at some point. To integrate this, what do you need to use? Or what should you use? Yeah, and this is one of the cases where, because of the deficiencies in my handwriting, I'm gonna use a W, okay? Because my N's and my U's, they look a lot alike. So W is equal to what in this case? Let's do negative n squared. Do you want to do n squared or negative n squared? Do you want to do negative n squared? Okay, we're going to be very careful, but this is what I would do. So yeah, so dw is equal to what? To negative 2n dn. So what? Oh, and there's also a dn right here. What does dn equal? dw over what? Yeah, I like isolating it here. Now we've done the w part. What's the second word of this method called? Substitution. We substituted up here integral of n e to the w, right? Times what? Over negative 2n. What's the magical thing that happens at that point? At this point, the coolest thing. If it didn't happen, we'd be stuck. The n's cancel. We're not integrating multivariable expressions. So what do we end up with? The integral of e to the w dw. What have I not written in very purposefully? You need the limits of integration. You better be careful. Can someone tell me? Oh yeah, I gotta put that up front. That's true. It's less important, but it's true. Ken, tell me what the limits of integration need to be. What's the bottom one going to be?
0.
Definitely 0. Can you tell me what the top one's going to be?
Negative.
Negative infinity. Why is it negative infinity? See that right there, everybody? If you don't put that negative sign in when you change the limits of integration, you get the opposite of the right answer. I'll show you why. Now, when we integrate this, we need to turn it into a what? Into a limit. So this is going to be the limit as b goes to, let's say, negative infinity of, what's the integral of e to the w? E to the w from 0 to b. We do the actual integration, we plug them in, we get the limit as b goes to negative infinity of what? E to the b minus e to the 0. What is e to the 0? This is 1, right? What is this though? What's the limit as b goes to negative infinity of e to the b? That goes to what? 0. If b was going to infinity, what would it go to? Kaboom, right? But because it's going to negative infinity, it goes to 0 instead of infinity. Therefore, our final answer is going to be negative a half times what? So it's 1/2. So if you don't change the limits of integration and you do everything properly, your limit is going to go the opposite direction. Yes?
Would it be okay to